there, welcome, and happy Sunday, data science streamers. I'm very excited to be here, doing something a little bit different today, and that's the sounds. As you can hear, today we're listening to some rock and roll, or just rock. I don't know if it's rock and roll, but it's pretty rockin'. And this is all copyright free, so I shouldn't get my stream muted or anything like that. I've never streamed data science to rock, but I just thought, let's try something different. I actually have really diverse musical taste myself, so rock is definitely cool in my book, and this is a lot of independent, up-and-coming artists on this Spotify channel of copyright-free rock. So, without further ado, my name is Carl. I should shut up about the music and talk about the stream. This is supposed to be a stream about data science. I'm not really much of a music critic, but I am a decent data scientist. So we're going to do some Python and SQL, talk about what's called customer churn in today's stream. If you've seen my streams before, I start out with a bunch of chit-chat, kind of giving the background and explanation. So without further ado, what is churn? Churn is when customers quit, and that's very important for all products and services nowadays. Whether it's a paid subscription, an in-app purchase, or an ad-supported product, you want your customers to keep coming back. Just like I want all of you watching this stream to keep coming back. If only I had some great data to help me make a better stream. Maybe that's in the works somewhere. Anyway, churn comes from a term called the churn rate, which means the proportion of customers that drop out, like 5%. And we calculated churn rates in my streams a couple of weeks ago. If you want to see that, the best one was on Manning's channel, my publisher. But you can find all those linked from the site. Anyway, churn is also now a verb. You can say the customer churned, or I'm churning from Netflix because I decided to read books instead. The subscription to my local library is free. I don't know, just kidding. I think I'm going to keep the library and the Netflix, and churn is also a noun. You can say make a churn report, or even the customer is a churn because they canceled last week. So that's all the churn lingo. Why churn? Well, it's really the most common data science problem in the world, I would argue, unless someone can tell me, otherwise, because every online product or service now has a churn problem, just because they want to keep their customers. But churn does require some special techniques. Yes, thank you, Maddie. Reading and Netflix aren't mutually exclusive. Except there is only so many hours in the day. So at some point, streaming, Netflix, reading, something's got to give. Anyway, this is also a great place to learn some data science foundations, because studying churn, you go from raw data to actionable results, which is what we're trying to do here. All right, let's keep moving. What was Fighting Churn with Data? That's my book. It's out now. It's what this stream is based on, so you can find it at my publisher's website with this discount code right here. It's also now on Amazon, so if you have the free shipping thing, more power to you. So that's what the book is. What was Zora? That's the company where I have my day job, and it's where I worked on all these different churn fighting cases that I got the experience to write this book. Zora is in the background. We're a platform that many of these, the companies shown here, they run their business, meaning like they manage their subscribers and their plans and their billing. So Zoom is a Zora customer. Zoom, see their name right here? Whoops. They run their business on Zora, and that means that if you subscribe to Zoom, your data goes into Zora's database of subscribers, because it's like on the back end. Anyway, I worked with a lot of these companies on churn, and that's how I, got all the experience. I had a unique perspective on churn because most data scientists study churn at the company where they work, but I studied churn at many different companies that were all running on Zora. Okay, so that's what we're talking about. What is Fighting Churn with Data really? It's a set of techniques or practices or strategies all under data-driven churn reduction. The most important one I always tell people is to make a great product, because if you have a great product, your customers won't churn. But how can data help? Well, you can find out, hey, thanks for the follow, Nicole Janeway. Hey, I know you. We're connected on LinkedIn, and I signed up for your email list, which is pretty cool. So nice to see you on the stream. Anyway, so what was I saying? Make a great product and use your data to find out what your good features are without using, hey Nicole, without using surveys. All right, also you're gonna do some marketing. Product-led growth. That's right, I should be up on all my SaaS lingo because I work at a SaaS company. Anyway, you're also going to use your data to do targeted marketing. You want to tell your customers about all your great features so they know what's so great about your product, but you want it really targeted. You don't just want to spam everyone. So you actually use the data to figure out who's using what features, who's not, who are your power users, and give them appropriate information. All right, also customer success and support. You're going to use the data to figure out who's failing on your product and reach out to them. And lastly, sales and pricing. So you don't actually want to give out discounts to reduce churn. You want to have a tiered pricing plan, and with like a basic, standard, and premier tier, so that people who use your product different amounts can still get value, but without you giving out discounts, because that undermines your pricing structure. Whew, okay, I think that's all the background. I'm going through that faster and faster the more times I do this stream, but hopefully it still makes sense for people who haven't heard me before. So there is some setup. If you want to follow along with the code that we're going over in this stream, it's all in the GitHub repo shown here, Carl24K, Fight Churn. And to get started on this, of course, you have to clone the repo. All the code uses Postgres and Python. Postgres is a database. If you haven't heard, just like throwing out the lingo there. And you run a data simulation to create the data that we use for the book, because I didn't really have real data to give you for the book. I present real data case studies in the book, but no real company will give away their churn data. It's their valuable customer data. So to do the simulation, to do the studies in the book, I should say, you use a simulated data set. Yeah, Postgres, thank you, Maddie, is definitely, well, I'd say it's my fave, but I don't know that many other things. I mean, I do use MySQL, but in my company, we're on an older version of MySQL, so it's not fair. I would say, like, I like Postgres better, but I'm just thinking about the fact that I use a new version of Postgres, whereas in production, they're on, like, MySQL from a few years ago. Anyway, that's life. All right, moving forward, let's look at some data. So what about the data from this simulation? We're going to need it throughout today. So I'm going to go over to my database here and show you there's two types of data produced by the simulation. One is subscriptions, which are shown here. So every subscription has an account ID identifier shown in this column. And every subscription is for a product. These are not the most interesting subscriptions because they're just simulated. And they all have, like one price, and they're all for 1 month, and they're all for one product. But you can see that they're sequential, which we call co-terminal or co-termed. So this account, their first subscription is entered from January 5th to February 5th. The next one is February 5th to March 5th, etc. It depends. In some systems, you wouldn't even call this a subscription. You might call it like a subscription segment or something like that, because each one of these is just one period. But you see different practices in the field. Some subscription products, they enter a new subscription entity in the database for each period. Others, they keep extending the end date. Others, they have no end date in the end date column, which is shown here. Others will have no end date, they'll have a null end date, and then they enter the end date when the customer cancels, and that's what we call an evergreen subscription. All right, so that's a lot of subscription lingo. We're going to be looking at subscriptions more later in the stream. There's another type of very important data in this database, which is the event data. Let's go to select some event data here. Okay, here's my last query from last week, which we're going to be getting back to. And in the event table, there are events, and I'll just select a few to get started. Make sure I'm live here. Okay. So events have an account ID also, and a time and a type. This isn't very interesting because you can't see the types. So there's a type table for the events, which I will join to. Oops, if I can type. Let's see. Event type. So here's the type table, which will show us what these events are. We do the join. And again, this is just for demonstration purposes. Let's see, order by event time, because we don't just want to see the same account and event. All right, so here we have a better selection of events showing from our Postgres database. So all the events have an account, and so you need to identify your events to the account to make all this work. So you need to be tracking your users as they use your product, although you're not stalking your users on the internet here. This is just like the plumbing of your product, although again, this is simulated. So every event has a time, and also there's different types. Now this simulation is for a social network, so the events are like post, new friends, viewing ads, more new friends, more ads, liking, etc. And so this is the underlying data of most churn fighting efforts. You basically have a bunch of events that they call it the product instrumentation sometimes. Usually people use a product to collect these events in a data warehouse. And those products are things called like amplitude, omniture, segment. There's many products that will collect these events from your product after you instrument it. Mix panel is another one. Yeah, so that's the data that the simulation creates. It's just events and subscriptions, and then everything else we do in the churn analysis derives from those basic entities. So turning back to the talk track, that was the data. The next thing we did with the data was calculating metrics. And this was what I called an in-database metric calculation, where you go from big data events, which are the point-in-time events for each account. You aggregate them, and then you get metrics, which are for the summaries for each customer at different points in time. And I say your metrics are going to be medium data, smaller, because you summarize the events, and you don't calculate the metrics constantly. You summarize them at different points in time. So let's look at the code real quick to go over events. And we'll just do over metrics rather. We'll just do a demonstration of what calculating metrics is like by going to the PyCharm IDE. And I can show you one of these SQLs. This is the basic metric insert SQL. So I said it's an aggregation, and I mean that literally. So there's this group by account ID and metric date, and the metric date is the date of the calculation. And the aggregation is just a count, but it's limited to a particular event type and events that were within 28 days before the metric calculation date. So that's how we calculate metrics. I can actually show you a quick event count SQL. I mean, this is just the basic SQL. We can run it real quick to show you what it spits out if I use one of these existing configurations. I want to do chapter 3, listing 1. It's just our basic metric calculation. And when you run a SQL in the framework, this is, whoops, I'm crashing. I think I've got the wrong schema setting. All right, I was using this for something else. So these are the arguments. This is running with the wrapper program provided with the book code. And so if you do the setup explained in the GitHub repo, you'll have this program. And it also goes over how to set up these configurations. And I also did it in a previous stream. I went over how to set up these configurations and make them. So every time it runs a SQL, it prints out the SQL it just ran, I should say. And you can see that the bind variables get filled in Up here in green with the percent beginning, you can see a bind variable, and you can see that that gets bound to a date. And similarly for the event, this starts out as a bind variable, and then it ends up as the like event. And here's the output. And so it's just showing for all these accounts how many likes per month they had on that particular date. And this is just a demonstration query that prints out the result. The real saving in the database is done with this query that is basically the same, but it has an insert statement as part of it. And that was all in a previous stream too. So this is all just kind of like the background, but I have to do it in case people are just watching this for the first time. So that was the basic metric insert. And so in previous streams, we did metrics summarizing customers, events, and subscriptions. We just wrapped this up yesterday, actually. We were doing the tenure metric, which is how long a customer has been a customer, and the MRR is the revenue of a customer, and we talked about quantity and billing metrics. So we also did a bunch of quality assurance on these metrics. And that's very important, and I'm showing here the order that you're supposed to do it in. One is QA your events by doing things like time series, and we'll look at an example in just a sec. Then you calculate your metrics, and then you do another QA on the metrics themselves after you've calculated them. And we looked at a lot of examples of that in the last stream too. All right, so here's an example of the QA we ran on the metric coverage, I call it, because the most interesting thing it's showing us is what percentage of customers have a value for each metric. And this is a very good quality assurance check after you've run your metric calculations. And it's also showing the average, the minimum, and the maximum. So we can see the average account has a tenure of just 59 days. That's what this first one means. The tenure means how long they've been a customer. Went over that last stream. They watch 32 ads a month on average. They have 16 dislikes per month and 100 likes. So very liking people on this social network that we've simulated. And this was done with a simple aggregation. We can go to the code real quick and look at this. That was listing 3.8. So listing 3.8 means chapter 3, listing 8. And you can see this is just, like I said, it's just an aggregation over each metric. The only clever thing is that we actually count the number of accounts in a separate common table expression here. So then after counting the number of accounts with the metric, we divide them to get the percent with the metric that I call the coverage, and then do these other statistics. So we're not going to go too much into detail on this quality assurance, but there is a quality assurance that we did last stream that we're going to go into more detail on, because in the last stream we witnessed a very sad event. I found a bug in the code that's in the book that's already published. So I fixed it on GitHub. So this was in the last stream. Anyway, we found this problem where it was supposed to be using an outer join to detect the number of events to show days when there was no events, but it wasn't working correctly. Let me show you the way it's supposed to work, actually. So this was like listing 3.9, I think. Let's check what that was. I'm going to go to, I think I've got the fixed listing here. This is the fixed events per day listing. In a minute I'll do a diff and show you the old ones, but I want to show you how it works first. So let's go to, what do I have to do here? I want to run, yeah, this is right. This is listing 9. I also need to do 10. Yeah, versions 1 and 4. Okay, this is going to be a quick couple examples to show you this listing working. And then we'll look at the result here. So this is it running. So it's running listing 3.9 on one event, which is the ad views. And that was where we were having the problems, because what happened was I deleted the add views to make an example of what happens when you have bad data or missing data. And it is now doing the count per month. And what it's supposed to do is show you the days when there are no add views. And it's still running. Takes a minute. And what I fixed, and maybe I should actually just go to look at the code while this runs. How am I going to show you the code? Let's go to GitHub, because I committed this already. You can actually see the fix in a branch on GitHub. This is my blog site. It has links to all the stuff. And this is the GitHub repo. Let's see. So I just did this yesterday. I have like a new branch. Okay, the event QA bug shown here. And let's do, I think I can do a comparison. And I can see what I changed. So this is how I changed the SQL right here. It used to be, you can see in the red, maybe I should make this a little bit bigger for people looking at this on a small screen. The point of this was to select the date and the number of events, but to also show dates when there are no events. And that's why the query uses a generate series to come up with a list of dates. And the way I changed the query is I made another subquery or common table expression to select the events of the appropriate type first before doing the left outer join on the date range. And in my old query, you can see here that I was selecting the events and the count. I was doing a left outer join between the dates and the events. That stayed the same. You can see this line is pretty much the same as this one. But what changed is I'm now pre-selecting my events in this little table. And so these were the changes I had to make to get this outer join to work correctly. And you can see this in a branch I made yesterday, 1226 event QA bug. And so now the result that we want to get, let's see how this is running. So all right, so it looks like everything has run while we were there looking at the diff. And the correct result is going to be this. Whoops. I always have this problem with the pictures opening up in the other window. So here we go. So this is the way it's supposed to look when you're missing data in the event count, because it clearly shows you the month of April where there are no events. And then in contrast, the healthy metric was this one. This is what it's supposed to look like when you're just measuring your events every day. There's more events in certain parts of the week, but that's what you see on most real services, and that's how I did the simulation, to make it look the same, like a real service. And then this is how it's supposed to look when you have this problem of missing data. But the earlier query that I was using, let's see, how am I going to get back to that one to show you the old? I don't actually have the old version anymore to show you. But the earlier version was going straight from February to April and skipping the days with no event, which I actually went to a lot of trouble, in this query. Well, even in the old query, I was trying to show those days, but I wasn't doing the outer join correctly. I'm actually still not totally sure why this didn't work, the old version. So again, in the old version, I didn't pre-select the events, and I was doing a left outer join from the events to the dates, but then an inner join on type, so it might have been something with this. But anyway, so that's the explanation for the bug that we found in the last stream. And this is the fix. I've got it in a branch here. I should make a pull request on my own GitHub repo. I probably won't, because I don't, I'll probably just merge it. no one's going to review it for me. But if anyone wants to give me a code review on this, I would appreciate it. Yep, thanks. Squished that one. It was, I guess, a little bit satisfying, but it's a little bit, messed up. I mean, it's already in print, so I can fix it in GitHub, but it's only going to get fixed in like the second edition. I mean, I don't know what other coding book authors do. I guess it'll go in the errata. There's like an errata page. So that was the bug fix from last stream. Took me a little bit of stepping away from it. What I realized, the way I figured it, I realized it is that I was doing it correctly in the metric QA, which we looked at also. This was the metric version, where it's also using the left outer join. This is listing 3.6, where it's doing a related QA, but it's a time series on metrics, where you also want to show the date. And this version worked, so I basically copied that pattern. And I'm not enough of a SQL expert to actually tell you why the old one didn't work. Anyway, so that was the wrap up, I guess, from last stream. That's actually not what we were supposed to be doing today. But this is the new subject for today, which is making datasets. So making datasets, I think, is a really cool part of my book because a lot of people don't actually know how to make a dataset, especially people who have been trained, in an academic environment. You usually just get a data set dropped in your hands and it has, the right number of rows and columns and everything's all set up for you. But once you're a data scientist out in the field or the real world, whatever you want to call it, you have to make your own data sets. And that's usually where most of the work is. People often say, quote, 80% of data science is like data janitor work. I don't see it as just data janitor work. I see it as really, this is actually one of the key step, or one of the most important steps in data science, is making your data set and deciding what goes into it. And that's really where your success or failure on a data science project is usually determined. So I'm really excited to talk about making data sets because most people don't. So the first thing we'll talk about is an easy beginning to making a data set, which is a current customer data set, where all you have to do is flatten the data from the database. And I'll show you what that means in just a sec. We'll hit some code. Then we're going to look at making a historical data set, which is more complicated. But let's first talk about the current customer data set. So this is what I mean by flattening the data, for those of you who haven't seen or heard this term before. Some people call it pivoting the data. I even call it pivoting the data sometimes. Rubber ducking always helps. Possible to overstate the importance of good data. Yeah, absolutely. I mean, what you decide in the data set determines everything. Now, this flattening the data is actually a technical step where the way data sets work, if you haven't seen it before, is that every row is for one observation. So like in this example, and the data set is on the bottom. On the top is how the data is stored in the database, in the metric table. We didn't look at the metric table, but we could in a minute. But it's like any table. You have a column for the account, a column identifying the metric, and then another column which gives you the value for the metric. So all the values are in one column, but then in your data set, which we're going to create, you need all the values for the same metric in the same column for all customers. So the first column has to be all logins per month. The next column has to be all posts per month. The next column has to be et cetera, et cetera. So this is called flattening the data because in your database, the data is in a tall format like this. And then in your data set, it gets wide because it's one column per variable. So it's sometimes called flattening. Now, you will learn the SQL flattening data trick. I don't know if there's a better name for it. If anyone watching this knows what the proper name for this trick is, let me know. And if you don't know this trick, you really should, because this is probably the most important single trick for making a data set from SQL, or really just generally extracting data from SQL. The trick is to use an aggregation. So with my crazy color coding here, you can see we're going to select for account ID. So each account has to be on one row, remember? So we're grouping by account ID. And the trick is to use a sum, an aggregation, and a case statement combined. So we'll look at this in a real SQL in just a sec, and we'll run it. But here I want to show you the trick. So to select metric 1, you do a sum around a case statement, which says when the metric ID equals 1 for metric 1, then you take the value, otherwise you take 0. But you wrap that in a sum so that, and group by account, so that if you, assuming for each account you have just one value of the metric, which you should for any given date, then this SQL will basically select out that one value for the account by using the case logic and the aggregation. And then for the next metric, we do metric IDs 2, and this gives you metric 2. So this is the SQL data flattening trick. And this brings up the infamous Data Ninja. Yes, that's my Data Ninja guy. Let me do a Data Ninja in the chat. Is it a Data Ninja or an acorn? I'll make a Data Ninja maybe sometime this week. I'll make a better Data Ninja sometime this week. But even though my Data Ninja looks like an acorn, this is an awesome Data Ninja move to flatten a data set. So let's look at it in a real example by going to listing 4.6 from the book. Let's see. Let's close some of my excessive tabs first, and then go to listing 4.6. So we're actually going to the end of chapter 4 first. I kind of teach it in a different order in the book. I focus on the analytic data set, and then I teach this current customer data set. But I wanted to show the flattening trick first, and this is it. So in this, I call it a current customer data set because it's just all the customers at the current time. And this is what you would use for segmenting your customers to do things like email them or reach out to customers who need help. So there's a little CTE, common table expression, which gives you the maximum metric time. And it's assumed that whatever is the last date that you have any metric, you have all the customer metrics. Now, another way you could write the same SQL would be to just hard code the date. But once you pick a date, this is just a repeated version of that trick I just showed you. The sum, the case statement with one metric ID selected. And then the rest of this is, well, this is an inner join on subscriptions to get the active subscriptions at that time. It's possible you could have event and metric data for non-active customers. So I'm going to make a new configuration here. We're up to chapter 4. Just in case I want my chapter 3 configuration, I recommend just duplicating these configurations once you have them set up. So this will be listing 6, chapter 4, and that's it. And this doesn't take a huge amount of time to run. I'll just run it. There it goes. So, see, it's already done. And it saved it, should have saved it in the same folder where I have all those other files. Let's see, yeah, here it is. I don't know if you can read that little text, but it says current customers. And if I open it up, it should just pop up in Excel. In the wrong screen, of course. And so here's our first data set. And this is a current, what I call a current customer data set. So it turns out that in this database, the last date that has the data appears to be May 10th. How many rows in this data set? Let's just take a quick look. 14,641. Oh wait, no, that's the ID. It's actually 11,394. That's the ID of customer 14,641. So the first column is the account ID. I include the date here in this column. Even though all these customers have the data for the same date, and we got that date from a query, it's a good practice to include a date like this in the data set itself. So if you ever open up this file later, you'll know what data Oh, how many rows in the raw data set? Oh, not in the flattened data set. Ooh, you mean like in the metric table? So there's a metric table. Maybe that's the question. For that one date. I mean, there's different ways to define the raw number of rows, Matt. It could be, yeah, count. So count one from the metric table. Let's see. I mean, this is the number of metrics that we've calculated. Don't need this. But that's not all the rows from that one date. Where, let's see, metric, is that it? Date equals, let's see. No, maybe I mean, oh, I meant metric time. Yeah. Okay, 91,463 would be the number of rows in the tall table for that metric, right? So 91,463 metrics available for that date, and then we flatten it to around 11,000. So about 9 to 1. Kind of makes sense. It's not exactly, because another thing to note about this query is that we're filling missing values here. So when we calculated metrics, we actually didn't store zeros. Whoops. What do I want to show you? I want to show you the query again. Here. So when we calculated metrics, we actually didn't store zeros, which is something I generally do to save space in the database. Because some of the events could be rare, for example. If you have a very rare event, and then you do a count metric like this, counting the metrics, the number of events per month, you could just have zeros for most customers. So I actually don't store the zeros just because it's a bad practice that in the limit where you're working on a data set with a lot of rare events, you'll just end up storing tons and tons of zeros. So I don't store the zeros, but I fill them back in here by doing these sums. That's actually just a good thing to note. If there's no value for a metric for a given customer, they'll get the zero. And that's where all these zeros get filled in, particularly in the unfriend per month metric. You actually don't, you see a lot of people who don't have any unfriends. If no event was captured, you wouldn't have it in the raw data anyway. Yeah, I mean, it's just, yeah, it's exactly the thinking here. It's based around the idea that these metrics are generally counting the raw events, or you're often summing like a property of the raw events or something like that. So yeah, here's the first data set that we made. It's not good for doing historical analysis. It's good for segmenting your customers as they are today. And by segmenting, I mean just, picking out people who all meet some criteria. Like let's say we wanted to reach out to all our customers who had lost a lot of friends and give them advice on keeping their friends on the social network. So let's see, you would basically just go in here and say, okay, show me all my customers that have 3 or more unfriends in the last month. And then you could do like an email campaign to, help these poor unhappy people who are unfriending all their friends. So that's what I mean by segmenting. And so this data set is suitable for segmenting because it has all the customers as they are today. All right, let's talk about but when we do data science, we're more often talking about what I would call a historical data set. And that is a data set where you have outcomes. And the outcomes are like, well, for a churn problem, it's who churned. But in any data set, you generally have an outcome. If you're trained in statistics, you would call that the independent variable, the variable that you're trying to explain. And so for churned data sets, you make a historical data set because it's going to involve your customers who either churned or did not churn. And that's what's going to be the rows in your data set. Each row is going to be a customer who churned or didn't. And so here I break it out into different parts. The first part is to find the active customers. And that's because in your data set for understanding churn, you don't just want to look at who churned. You also want to look at the people who didn't churn. Because it's just like in any analysis, you need both positive and negative examples, right? If you're familiar with data science, you already know that. And if you're not familiar with data science, well, I'm teaching you right now. You need both positive and negative examples to do an analysis. So you can't just look at the people who churned. And it's kind of like a beginner mistake to be like, oh, let's understand the churns. Who's churning? Let's just look at the people churning. And then they don't compare them to the non-churners. That's what CSMs and generally non-data people will tend to do. Anyway, so for this process, we're going to find the active customers, find the churn customers, and I mentioned that we need to find their start dates because that's actually the key hard part of this, you'll see. Then we're going to make observation dates on which to look at those customers. And then finally, we'll make a flattened data set. So we're going to go through all these different parts of the process. So you can see that making a current customer data set is a lot easier. All you do is pick a date and flatten all your data for that date. But for the analytic data set, which you're going to use to understand the customers, you have to go through a lot more steps. All right, okay, so here's the overall picture, and this is a figure from the book. So we start from the subscriptions, which we looked at earlier in the stream. Then the first step is identifying active customers, and then identify churn customers. And the active customers are going to be your examples of non-churns, some of them. And then your churn customers give you all your churned examples. You'll see that the churn customers also give you non-churn examples if they renew. But we'll get to that. So from these identifying the customers, we'll find observation dates, which we're going to basically pick times to observe the customers, which we'll talk more about. That's what the rest of the stream is about. And then finally, you take the metrics, which we've already looked at, and you join those with the observation dates. And that's where the flattening step comes in. So this is the overall process we're going to go through now in the rest of the stream. And again, this is all from chapter 4. So let's see. First part of the dataset creation is finding start dates with messy subscriptions. And I talk a lot in the book about messy subscriptions because it's the reality that I've had to deal with. And by messy subscriptions, I mean subscription databases when you can have multiple subscriptions per customer and you can have gaps in the subscriptions. And it's not just like one subscription per customer. That would be really simple. If you just had one subscription per customer, it would be really easy to find the subscription start date because you just look at that subscription and look at the start date. But if you use a complicated subscription system, it might look more like this. So let's see. So on the left is an example of a single subscription where the customer churned. Then this is an example in the middle where they had multiple subscriptions, but there might be a short gap between them. And that's another example of what happens in messy subscriptions. Like let's say the customer's payment card failed on their renewal, and then 2 days later, and then your system canceled them, right? And then like 2 or 3 days later, they corrected their card and they signed up again. Now, we wouldn't call that a churn because they've only been, their card was only inactive for a couple of days. But if you have a lot of stuff like that in your database, it can mess things up. So the algorithms we're going to look at are designed to handle the messy subscriptions and to identify churns by to identify the start dates. That's what we have to do. The hard part is identifying start dates. And it's actually very related to the account tenure calculation algorithm that we looked at in just the last stream. I went into it in a lot of detail. the algorithm for calculating the account tenure, or customer age, some people call it, uses a recursive SQL expression. And we're going to use the same one for this. So let's see. I think we're ready to look at the next SQL. Yeah, so this was what we did in the last stream. This is a review for anyone who watched it. This is an example of a recursive common table expression for account tenure. And the common table expression is the SQL in between the parentheses. So you have the recursive statement, which tells the SQL engine that this is going to be a recursive query. And then there's an initialization, which is the top select, and then there's the recursive query, which is the bottom part. And the top select initializes by finding for each account the start date of the currently active subscription. And then the recursive query joins those accounts with their own earlier subscriptions, where the end date of the earlier subscription is within a certain range of the new subscription. So ideally they would be co-termed, they would just meet up, but you can also have a little gap, and that's taken care of in the where clause here. So this was the SQL for finding recursively the age of each account, and we went into it in lots of detail in the last stream. And now we're going to, and this got the Data Ninja ranking, because recursive common table expressions is pretty advanced, and finding the account tenure is a really good example of using it. So this is the same technique for finding the active customers. I call them ongoing active customers because, we call them actually ongoing active periods. The periods actually refers to what we're going to write into the database. So this is, with a little fixing, this is the query shown here. And this is the recursive keyword, and this is the actual recursive query. This just gives the parameters of the query, which is the date that you're calculating for. That's the nominal date that you're making the data set for. And this is how much of a gap to allow in between subscriptions. And these variables get used, down later. So the initialization query selects account IDs and the minimum start date for the currently active subscription. And then the recursive query adds the account ID and the start date for earlier subscriptions. So we're selecting from subscriptions, joining with our earlier active. This is the name for the CTE here is active. And then, we take where the start date of the earlier subscription is less than the start date of the active subscription. Ooh, I used a bad letter. I named the active E. It should have been A. Sorry. And then we want the end date to be within the allowed gap from the start date. And then the final records we select are the account ID, the start date, and we select a null as the churn date. And we actually insert this all into a table called active period. And the active period is basically just the concatenation of all the subscriptions that the customer had active. So let's try running this. That will make this much more fun. Oh, you use 3-letter aliases. Yeah, I should use 3-letter aliases. Coding style is one of those things where it's like, do as I say, not as I do. I always have a lot of good coding advice for when I give someone else a code review, but I hate to hear it when it's my own code review. So let's just run this and then look at the result. It doesn't take that long. Yeah, it already ran, but how do we know anything happened? That's the question. So this was supposed to be an insert. So we're going to go to the active period table, and let's, actually, hold on. I want to get one thing first. I want to get my copy a set search path statement here. This will make it easier to do some more SQL hacking. Once I do this, then I don't have to keep entering the schema. So let's just do select star from active period. Let's look at the result that we got. All right, so for account 1, it says we started on January 5th and there's no churn date. So now let's do a new query. Select star from subscription. We'll just look at that account's record, his subscriptions. So here we can see that he has a bunch of subscriptions. He does indeed, or they, it, them, it's just an account ID. Starts on January 5th, and their subscription is continuing to June 5th. So on the date when we made the data set, they were still active. And now let's try actually looking at account ID 2 and see what happened to them. Because they don't show up yet here, and that's probably because they churned. So account 2 churned after April 18th. So that was why they didn't show up in the active customer data set. Okay, so that was the first step of calculating the analytic data set, finding all the current customers and the date they started. And they don't churn because, you know, they're still currently active. All right, that was step 1. Again, this is to situate you in this long process of creating a data set. Step 1 was find the active customers. Step 2 was finding the churn customers and the start dates. And I should warn you that this is just about one of the gnarliest sequels in the whole book. It's probably the second to worst. Because, hey, true data ninja, right. Let's do some real data ninja stuff. And look at listing 4.2. It's called the churned periods because it finds all these customers who churned, and then it enters their data into that active periods table. Actually, you know what? I'm not supposed to show you the sequel yet. Let's look at some talk. Okay, here's the illustration of finding churns in messy subscriptions. So remember, you can't just look at your subscription database and look for the churn flag. There is no churn flag. Churn is a state of a customer at a particular point in time whenever they used to have a subscription, but they no longer do. And any churned customer could become a non-churned customer again in the future by re-signing up or reactivating their subscription. Or if there is no subscription, they might just come back to your product or service. So your data is going to be messy. How do you find subscriptions? And that's illustrated by this example where we're assuming that the end of subscription 5 was a churn because there was a long gap before subscription 6. And also the end of subscription 1 was a churn because there was a long gap before subscription 2. But in between this subscription 2, 3, 4, 5, there was no churn. And the key to finding churns is finding what subscriptions have no other subscription coming after them, which for this purpose I call an extension. So in this example, subscription 3 is like an extension of subscription 2 because it comes after it within a short range of time, rather. Similarly, subscription 5 is extending subscription 4, which is extending subscription 3. But subscription 6 doesn't extend subscription 5 because it's like 1 year later, according to this hypothetical example. And subscription 2 doesn't extend subscription 1 because it's, here I'm saying it's like 4 months later. And that would be too long, you know, to consider it an extension. So, also I should mention the extensions of a subscription. I keep making my little quote-y symbol because that's not a proper term that's used in the industry to analyze churn and subscriptions. It's what I call it in the algorithm. So we're going to do an algorithm in SQL that is going to find these subscription extensions to find the churns. And then well, actually, I think I've got another slide on it. So this is the overall SQL for finding the churn customers. You take the subscriptions and you find end dates for the current subscription, and then you find extensions for the end dates, and that's how you. And then you do an outer join between. We'll do an outer join to find the subscriptions with no end dates, and those are the churns. Better say that again. So remember, going back here. Whoops. We want to find the churns, which are the subscriptions with no extensions. So how do you find no extension? Well, you can't use an inner join. You could use an inner join to find extensions, right? By doing like a little date logic. But to find the churns, you find subscriptions with no extension by outer joins. Then once you find those, you have to do your little recursive trick to find the start date, given the churn end date. So this is why I said this is like the most crazy SQL up to this point in the book. This is like chapter 4, and this is the worst SQL yet. Let's look at the worst SQL up to this point. There's maybe a worse SQL in chapter 6, or well, worse algorithm. This is probably the worst SQL. This is the churn periods. Okay, so what are the different parts of it? All right, Maddie, thanks for joining. I know it's actually, it's actually late where you are. So good night. And yeah, this is not my Europe-friendly times stream. That was yesterday. But glad to have anyone who's a night owl in Europe. Let's see. Okay, so as usual in these SQLs, we define a few variables in a CTE at the top. These include the allowed gap, which will not be considered a churn, and also the start and end observation dates. Ooh, 1 a.m. in Central Europe. Yeah. Well, what time is it here? It's like 4. So, yep, do the math. 7 hours. I guess it's the winter, so okay, I guess it is only 7 hours. Right. So, okay, the next part of the SQL is finding the original end dates, which is actually pretty easy. These are, again, let's see, what are we doing here? We're finding the account ID, start, end date, active period params. Oh, okay, so this is finding all the subscriptions that end between our dates. These are the dates that we're defining, the observation dates, or the period for which we're going to run the SQL. The end dates are going to be all the subscriptions that end. You know what would be better is we'll run this and then we'll break it up and put it into the SQL tool. But first, let's keep going through it. So this next part is the re-signups. So this is finding end dates, let's see, where there is, God, I haven't looked at this query for a while. I might have to redo this stream when I'm familiar with the SQL. So this is finding, again, accounts and the ends of their subscriptions where, let's see, the start date is less than the extension. Okay, so this is using the first end date query and finding all the re-signups. So it's finding new subscriptions that come after all these end dates. So this is just a whole bunch of end dates. Oh, and this little bit is calculating the maximum date at which an extension can start. Okay, this is all coming back to me now. So this finds the re-signups that come after the end dates. And then the churns is actually here. It's actually it's the initializer for the recursive expression is a left outer join between re-signups, end dates and re-signups, where the re-signup is null. So this was actually how we found churns in the churn calculation SQL from chapter 2. I guess I should have shown that SQL too, because that's actually part of the background for this. is that in chapter 2, there's a sequel where you find churns using this left outer join trick. So it's pretty similar here, that we initialize the recursive common table expression with all the churns by left outer join, finding end dates with no re-sign up, because this query takes all the end dates, even if there is no matching re-sign up, and then selects only those where it was null, which means there was no matching record. Now this part is finding the earlier start date. So this is actually familiar from the other sequels we've looked at. So it finds earlier subscriptions of the same account with an earlier start date, but the end date within the allowed gap. And then finally, it inserts this all into the active period table. All right, that was kind of a mouthful. Let's run it, and then we'll break it up and look at the different parts. So here we'll just run listing 2 from chapter 4. And this will print out what it's doing. So let's go from the beginning and select just this first section. And so this is the first part of the sequel, which was just going to just look at the results of this end dates query. Let's see, let's order by account ID and limit, so we don't have to look at so much. So this is finding all the end dates of everyone's subscriptions. Pretty easy, right? So you've got both account 1 and account 2. So these are all subscriptions that have end dates within this period from February 9th to May 10th. All right, what's the next part of the sequel? And go back and cut out here. So now we're going to select the re-sign-ups. Put that in here. I'm pasting on the re-sign-ups. You know, rock for data science isn't so bad. What are people thinking about rocking it out with data? Usually I do electronic, but yeah, it gets like my blood pumping for data. So here are the re-sign-ups, and these are all subscriptions which can extend an earlier subscription, right? Now I just want to select the churn query, because that's kind of the interesting part. I'm not going to do the full recursive common table expression. We'll just select the churns. So I'm adding each common table expression builds upon the previous one. So I'm adding them up here. So finally, we can select the churns. These are, so again, this is using the end dates, we find all the re-sign-ups that come after them using a left outer join, but then we only select rows where the re-sign-up was null, which is given by this query. Whoops. So, let's see, we'll order this by account ID too. Okay, so now we're only getting the customers that have actually churned, and this is going to be their churn dates. Let's go back and look at, so this is saying the churn date for account 2 was 4/18, and if we go back and just look at that account's subscriptions, you can see, here it is. 4/18 is their last subscription, so that means that's correct. That's when they churned. So let's see. Go back up to my last query, and we can look at some more. Again, account 4 churned on 3/3, and then these are the days that they started also. And you can verify that one too by looking at account 3. Actually, Oh no, it's supposed to be account 4, not account 3. Yes, account 4 churned on 3.3, not account 3. There we go. So I'm not crazy. Okay, so this is basically, hopefully, giving you some idea of what's going on in this kind of monster query that finds the churned accounts. This part finds the earliest start date, so I'm not going to go into that. But again, this was an insert into the active period table. So here we've got, let's go look in the active period table again. And now we're going to have some more stuff in the active period table. Now we've actually got churns in the active period table too. So after we ran the first listing, we only had the non-churns. And then the second listing added in the churns. And for all of those, it gives the churn date as well. I'm actually double fisting on this stream. I've got 1 coffee and 1 throat tea. So if you see me with 2 different mugs, one's for caffeine and one is just to, keep my throat healthy while I'm chatting away here. All right, so we're making progress on this, and we've got all the records in the active period table that we need. Yeah, it's a lot of talking streaming. It's kind of crazy, but anyway. So now we've got the churn customers and their start dates. And the next thing we need to do is find the observation dates that we're going to use for all this data. And this is a diagram that I show whenever I talk about how you want to observe the customers. Because the trick is, when do you want to observe the customers to make this data set, which you're going to use to understand churn? And what I'm illustrating in this picture is what typically happens when a customer is planning to churn. Usually some behaviors increase, but some behaviors decrease. And this is shown for, like, imagine a file sharing service. Someone decides they're going to churn around, this time here. And then after they decided to churn, they stop uploading. So their uploads go to 0, and then their downloads go up because they're planning to churn. So it's actually very common to see some behavioral changes right before churn. And you've probably done this too. Once you decide you're going to cancel Netflix or Hulu, you're definitely going to go in and finish the last season. You might do some binge watching. And for services that provide things like clip art, people will definitely binge download right before their subscription ends. So the problem with observing churn is when to observe it. It's if you observe the customer at the end, right before they actually churn, you're in that lagging period where the behavior has already been changed by the fact that they're planning to churn. And that actually makes it easy to find customers churning, usually. But the problem is, it's too late. At that point, they've made up their mind, and it's harder to win them back. It's also not good for understanding the causes of churn and why people, churn or don't. So I would say you want to observe people in this period leading up to the churn when they haven't made up their mind yet, and probably the lagging behaviors haven't kicked in. So it's actually harder to identify the churns, but at the same time, that's what you need to do, because that's when you want to understand the people in that state, and you also want to reach out to them. So we're going to try to make the observations in advance of the churn. Now, how do you know when it's in advance of the churn? You don't actually. But you can just do it. You want to observe the customer because he doesn't have arms. So if he falls over, he's going to need some help. Yes. He actually does have arms. They're just kind of like hard to see. But hey, I'm a data scientist, not an artist. And I had to make all these crazy illustrations for the book by myself. So this is an illustration of observing a customer on a subscription with a lead time. And the idea is that you don't know when they're going to churn, but you know when they are going to renew. And you basically can just pick a lead time before the renewal. So imagine these are monthly subscriptions, and he's renewing, or this person's renewing on every green line. That's their monthly renewal or payment. And then the red one is the one where they cancel, and assuming their subscription goes up to the end of the last period. So if you were going to observe that churn, you would observe them like 1 week before, the payment. Or if it was an annual subscription, you might observe them 1 to 3 months before the final subscription. So then you also need to observe the customer earlier when they didn't churn. This is actually an important part of making a churn data set, is to observe the customers that churned before they churned, and that will actually give you non-churn observations of those customers. So getting kind of complicated, but the idea is to make a sequence of observations where the final observation will be a lead time before the churn, and all the other observations are a lead time before the renewal or payment. And it's only complicated when I say churn so much. All right, sorry. I'm making it more complicated than it has to be. But thanks for the feedback. So, this is what we're going to try to do. Here's a little toy example, assuming like a monthly subscription. So your one customer signs up on the 13th of March. Their next payment is on 13th of April. So if we use a lead time of 1 week, we'll observe them on the 6th of April. And then we'll make sequential observations every month. Hey Trillfrags, thanks for following, and welcome to the data science stream party, or I don't know, whatever it is. Welcome to the data. Glad to have you. So our next account, suppose they sign up on the 22nd of February. Their renewal will be the 22nd of March, and using the 1 week lead time, we would observe them for the data set on the 15th of March, the 15th of April, the 15th of May, etc. Do we do any machine learning and deep learning stuff? Yes, we absolutely do machine learning, although we don't use deep learning for this problem because, well, deep learning is more for image recognition and audio processing. Churn is a problem with more structured data, so we don't really use deep learning for it. What we're doing right now is actually making the data set. It's like I tell a lot of people, in a typical machine learning or AI course, they just give you your data set and they say, oh, here's your algorithm, run this algorithm. But in the real world of data science on the job, you have to make your own data set. And what I'm actually teaching on this stream is how to make a data set from raw data. We're pretty far through the process at this point. Let me go back up. This was the process. So we're on this step 3 of finding observation dates, but pretty soon we'll have a real data set. I appreciate my positivity. Yep, got to clean up that data. It's not, but I always tell people, the other thing I tell people is it's not about the cleaning. I feel like the construction of the data set is really the true activity. You're taking the raw data and fitting it into this particular format of one observation per row, one feature or metric per column. And in that process, you're going to introduce some kinds of errors and find mistakes. So I always feel like you focus on the cleaning, that's kind of like, it's a part of it to be sure, but the main activity is the creation of the data set itself. So let's look at this next listing 4.4, the observation dates. And so that's chapter 4, listing 4. Do you ever take invariants and take out outliers? Yes and no. So we definitely do a normalization later. This is actually, now we're talking chapter 5, so we're still in chapter 4. But I don't actually take out outliers till later chapters. I think taking out outliers is like a chapter 8 subject. But we do take out outliers eventually. But for right now, we're just trying to get the basic data set created. So listing for the observation dates is the next key step. And this one, it works on so remember, we've got these active periods that we've created. So this is the raw material for selecting the observation dates. So basically, you have this account that started on January 5th, and we want to select those sequential dates. And they never churn. This account started on January 18th, and we want to select their sequential observation dates until they churn on that date. So let's see if I can explain this SQL to do it. Again, these are the bind variable parameters. So trill frags, if you haven't seen this before, I do all this stuff in SQL. So you extract the data from the database in SQL, and then you do your analysis in Python, which is probably what most people are used to. So anyway, this is selecting the observations. Again, this is another recursive common table expression. So if you go through chapter 4 of this book, you will be an expert in recursive common table expressions by the end. But that's what it is. So for each account, we initialize with the start date from their, let's see, this is again one of these complicated SQLs. I should have reviewed it before I was live streaming my explanation of it. Oh, you took a DB management course. Ooh, it was rough. TRC, out, and I forgot what else. Haha, ended with SQL though. Oh yeah, a lot of the stuff they teach you in database courses is, yeah, like that algebra, what do they call it? I don't even remember, it's so long ago I took it. And a lot of it doesn't tell you the cool SQL tricks that you really need to know, but I guess it's good for management. Oh yeah, relational algebra. It's been a few years since I did all that. But anyway, so this is another recursive common table expression. We initialize each account with their start date. Oh, hey, Near17, thanks for following, and welcome to the data party. Let's see. You're going to take relational algebra again for sure? No, don't take relational algebra again. But do learn cool SQL tricks. So again, let's see, there's a case statement. Okay, so this is basically selecting all the accounts and their start date. And then this is their observation days. Remember, it's plus one this is the initialization. So it's one observation interval, which is going to be like a month, minus the lead time, which will be typically 7 days, although you can set it as you wish. And then this case statement determines if this is their churn or not. And it would be their churn if the churn date from the active period table is greater than the start date and before, it's basically within the next observation cycle, then it's a churn. Otherwise, this observation is not a churn. So this is actually putting the outcomes in place for the churned and non-churned customers. Then we do the recursive common table expression where we advance the observation count for each account on each recursion. So we initialize the observation count at 1 on the first initialization. Then for each recursion on each account, we increment the count by 1. And we calculate a new observation date by adding the observation interval times the observation count. And I'll tell you later if you want to know why I don't just do this in a more simple way by adding like a month or something. This is the same logic for determining if this is a churn observation. And this is all the logic that you need to keep doing the recursion, to keep sequentially finding observation dates until there's a churn. And so this is another insert select into a table called observation. And the observation table also got created during setup. So let's try running this, and then we can maybe take some pieces of it out and run them individually. Wait, which one was this? 4, 5? or no, 4.4, sorry. Okay, so this is gonna run it. I hit the run button. So that means here it's printing out the SQL that runs pretty quick, right? It just ran. And so you can see here I plugged in the bind variables from my configuration. So in the observation interval was plugged in to be 1 month. The lead time was set to be 5 days, which is reasonable for a consumer product. Most people aren't really thinking about their renewal until it's right upon them. So if you want to look at a customer like 5 to 7 days before their renewal, that makes sense for a consumer product. If it were a business-to-business product where you had a 1-year subscription, then you might use a 30 to 90 day lead time. And these are the observations start and end defined by the variables. So this put all the results into a table called observation, which we haven't looked at yet. So let's just select star from observation. Let's see. And it looks like they're ordered by observation date 2, which is what we really need to make sense of them. Yeah, I'm not varying the lead times. It's actually in a configuration. So this is kind of the background of the setup for this code. I wrote the code in such a way so that there are bind variables for all the important, configurations. And then it comes with a big configuration dictionary, literally in a JSON file that comes with a book. And I was showing this on earlier streams. And that way you can reuse the same code for different data sets. In fact, when I wrote the book, I had to work on 4 data sets. If you look in the book, there's 3 real data sets, which are real companies that I worked with, and there's 1 simulation. So I used all the same code, just configured differently. So that's where those things come from. Yes, book. Yes, there is this book. If you're just joining the stream for the first time, this is the book, Fighting Churn With Data. That's kind of like where all this is coming from. But the code is free, so you don't need to buy the book to get the code. The code's all in GitHub. But anyway, so it's all configured, and this shows you the observations we create for customer 1. 229, 339, 430, and these are all false, meaning no churn. So you can't read the little text, but the column name here is churn. Now customer 2 started on, their first observation was 213, 313, 413, and that was their churn observation, 413. And if you go back to, we were looking at customer 2's subscriptions. So remember, his churn observation is 413. You can see his subscription ended 418. Cool, you just bought a book from CentDex. If you know, I actually don't know. Big data science, Python, AI. Okay, cool. I'll have to look him up. Building a neural network framework from scratch. Yeah, well, neural networks, definitely cool if you're doing image processing. Not so suitable for this kind of problem, although it's kind of a subject of debate. I come down on the side of don't use neural networks for structured data because boosting algorithms generally work great and they're more predictable. But anyway, that's a deeper, longer subject. I'm going to try to get through creating the data set, which we just did, this important query for creating the data set. Let's see, I said we could go into the query in pieces, but maybe we should just keep on going. I don't know. Finish making the data set. Let's try that. I mean, if no one has any questions, we can go deeper into it. So going back to the program, it was to, yeah, you got to see how long. Fat books. Unfortunately, my book turned out to be kind of fat too. It's like 300 or 450 pages. Yeah, like 450. It was only supposed to be 350, but it kind of went over. Sorry. So the last step here was making a flattened data set from the observation dates. And we already talked about, oh my God, 600 pages. Ooh. Okay, yeah, 450, not too bad. And it's full of pictures and code too. Sorry about that. After an hour and a half of talking, my throat is kind of losing it. Good coffee recommendations. Well, personally, I'm partial to Bay Area locals like Phil's Coffee and Pete's Coffee, but I forget what I'm drinking right now. Anyway, the last step of this is to make a flattened data set. And so this was the overall process we were working on here. We started from subscriptions. We identified active customers. That was listing 4.1. Then we identified churn customers in 4.2. I'm forgetting now. The last listing we did was finding the observation dates, and we tacked on the outcomes of whether those customers renewed or churned. And the last part is to merge that with the metrics and make a churn data set. So let's look at that last part, which is listing 4.5, and it's just called dataset. Let's see, go over here. Listing 4.5 is the dataset listing. So if you were watching my stream earlier, you already saw the data flattening trick. And I think some of those people dropped off, so I might want to explain it again. This is the data flattening trick because we need to go from a tall data format in the metric table to a wide data format in the data set, meaning one observation per row, one metric per column. This aggregation does that by wrapping a case statement in a sum and taking 0 for the metric value when it doesn't match the ID, and otherwise taking the value. Assuming you're grouping by observation date and account, and so it's a given that you only have one metric per observation date per customer. That was enforced when we created the metrics. There's actually a unique index on that table. So this effectively picks out each metric and puts it in the column for the appropriate customer. And that's actually most of this SQL. We limit it to a certain date range. Well, we're joining the metrics on the observation table. So that's the key. We just filled the observation table with the last SQL, and now we are selecting the metrics where the metric time is within a week of the observation date. That's actually a little trick here, which is that because we calculated metrics only once a week, that's what I recommended, because in this case, it's not necessary to calculate them every day. So then we also need to select the metric observation that is preceding the observation date, but within 1 week before it. So it's saying metric time less than or equal to the observation date, and metric time greater than the observation date minus 1 week, which is that period. So this is going to create the data set, and if we just run it, it's going to save it. So we will finally save the data set. We go to run listing 5. This actually takes a couple of seconds to run. As usual, it's printing out the SQL with the bind variables filled in, a 7-day metric period, data set from February 9th to May 10th. And now it saved it. So if we go to the folder, we will see the new data set. And you can see here, it says data set. And if you listen carefully, you can hear my dog in the background. Can anyone hear that? He's freaking out about something. Probably someone at the front door. So, what you're seeing here, this was the current customer data set. And I was doing a little filtering example. So this data set has every account observed once on a single date. Now let's contrast that to the current customer data set, which looks like it's in a weird sorting order. So this is the historical data set. And it's different because there are different customers and different dates. And there's also this column for churn. I'm wondering, where are the other customers? It seems to not be sorted. Let's sort this by account ID and then sort it by observation date. Wait a second. I think I have another bug here. Oh no, this is good. This is good. No, it looks right. Sorry, I was like freaking out for a moment there, but this is cool. This is the way it's supposed to look. My eyes were tricking me. So now in the historical data set for the analysis, what is different is that we observe customers more than once because we actually observe them on each renewal. I'll zoom in even more here. So these first three observations are all account 1, and these are all dates when account 1 did not churn. Then we observe account 2, and we have these serial observations until the date when they churned. Actually, we can make this easier with a little conditional formatting. Let's say highlight it when it's equal to true, and now we can see the churns. And freeze the top row. So now we have these sequential observations for each account on the same date of the month. And most of them don't churn, but occasionally they do. So this account was a customer for 3 months and then churned. This account was a customer for 4 months, etc., etc. And then all of these metrics are from that observation date. And so now we've actually achieved what the goal was, which was to create a data set that can be used to analyze churn. And it can be used to analyze churn because it has both churns and non-churns. And something I didn't go into detail in explaining is that it also has churns in proportion to the true churn rate. So the percent of churns in this data file is going to be very close to the churn rate of your actual customer base. And that's also important for the analysis because it means that the churn rate that you measure or predict from this data set is going to match the real churn rate. And in order to achieve that, we observed customers on every renewal, not just the ones where they churned. So I think that kind of covers what I was trying to cover. So, wrapping up the stream on schedule, let's go over the summary. So, as I explained earlier, fighting churn is about targeted interventions, improvements, engagement, and support with your customers. Metrics summarize customers' events and subscriptions, and we looked at metrics like counts, counts of events, and things like the tenure, subscription events. Let's see, Chillfreds, you keep VODs up or are they sub only? This is actually a simulation, so there's actually no real data here. Unfortunately, I didn't have real customer data to teach people how to fight churn. And it's because it's, it's sensitive data. I mean, those are real customers, and I can't give that data out. So everything we do here is simulated, and there's just subscriptions. Yeah, it's not that realistic, but it's realistic enough. Oh, you mean the Twitch VOD? Let's see, what are VODs on Twitch? Subscription. I'm like not even. Oh yeah, definitely. Oh, I keep everything up on Twitch. Yes, I do. So I do highlight. Yeah, I do highlight everything. After every video, I basically make a highlight that edits out the part before I start, and then just leave it up there. I'm also going to put them all on YouTube. That's actually my holiday project, is to start a YouTube channel that has all my old Twitch videos. So, yep, no problem. Anyway, so we also talked about creating the current customer data set today, which we use for segmenting customers. So if you want to make groups of customers that have certain characteristics, you would use that flattened data set. And then we also went through all these steps about creating a historical data set for analyzing. Oh, thanks for saying the videos are cool. Wow, and cool name, Flash Spidey Boy. Good one. Wow, and you say my videos are pro too. I feel like a rank amateur with most of what I'm doing here. But I'm glad to hear that it actually doesn't look too bad. So in today's analysis, we did all these historical data set steps. Pretty complicated. Finding active customers, finding churn customers, finding the observation dates, and flattening the data set. And these are all the steps that you have to do when you're like a professional data scientist. No one gives you your data set. Like in your classes, you get used to just having a data set just dropped in your lap. Like, oh, here's your columns and here are the rows. And actually, it takes out some of the most interesting work as a data scientist, where you're actually deciding what the features are going to be. I actually think that's the most interesting part of the data science. Ooh, another cool name, Bathing Ape Supreme. This is, oh, yeah, sorry, it's basically wrapping up for the day. This was my stream for the day. I could go back into stuff, but I'm totally losing my voice, so probably going to call it. So let's see, this was the summary for today. Okay, this is my little slide saying that there's hooks. Oh, hey, Detox Mango, welcome back. Sorry you're joining right when I kind of finished. Maybe I should like do the stream over again or something. Here I was just saying where to get the book and Fighting Churn With Data. There's a discount code, 40% off, you can still use. This is actually going to be my schedule for the new year. I'm actually going to change it up a bit. And I'm going to do my afternoon stream in my time zone on Saturdays. I want to switch it up. And then Sunday, I'm going to do a European-friendly time stream at noon. It was different this year. Sure, you want to ask questions about quant finance and neural networks? For those of you who don't know, I actually worked as a quant for like 7 years before becoming a data scientist. So I have some quant background, although I was a fixed income quant, so I don't actually know that much about, equity, which is what, most people are asking about. Quantoplant. I actually don't know that one. Interesting. So what are the questions about quant finance? And I actually spent some time trying to predict asset prices with neural networks and support vector machines. Oh, for back testing? Yes, that's good. And I'm glad people know what back testing is. All the Greek letters in convertible arbitrage. Oh God, it's been a long time since I did that kind of stuff. I became a quant to answer that question. I had a PhD. I finished my PhD and it was actually in biophysics. So I was kind of a technical biologist. It was actually in a program that combined AI with neuroscience. So I did a PhD in biophysics, and then I needed a job, and I didn't want to stay in biology, academia, because I don't know if you know about postdocs, but after your PhD, you do a postdoc, and biology postdocs take like 8 years. So I didn't want to stay in biology, and I got a job as a quant, so I had a PhD. Yeah, all that school is kind of scary. And my undergrad was actually electrical engineering. So I went through a really weird career arc. I don't know if I'm really a role model for this, because I started out by electrical engineering. Then as soon as I graduated, I became a programmer instead of an electrical engineer. Then I did a master's in computer science, which convinced me to do a PhD in this AI bio program. And then when I graduated, I became a financial quant, and I was kind of wishing I had just studied statistics. I struggled in electrical engineering. I mean, all the courses were pretty hard. Yeah, definitely electrical engineering, a lot of hard courses. So I got into data science by I call it like the old-fashioned way because I did it before there was actually programs in data science. Now the most common way to get into data science is to get a degree in data science, right? And if you don't get a degree in data science, you're probably going to get a degree in statistics, which is practically the same because most of data science is statistics plus programming. So if you do a little programming in your stat degree, you're basically a data science. Most data science programs post-grad may be. And in the US, we would just say a graduate program for data science. Well, maybe it's not so common, but I know they have it here. I think of it as common. I'll tell you why. Because I get interns from University of California, Berkeley. So I advertise my data science internships to Cal, and they have an undergraduate data science program. So I get tons of I talk to lots of undergraduates in data science from UC Berkeley. So to me, it seems normal to have a data science undergrad. But I guess it's true that for most people, Berkeley is a bit ahead of its time. Yeah, they have a lot of stuff. I mean, we're in the Bay Area here, so most people are probably going to do an undergrad in statistics or CS, and then you could do graduate or postgrad, how you get into data science more commonly. Definitely true. Yeah, definitely econ undergrad is a good way to get into data science too. In fact, that's one of my preferred majors for hiring interns and data scientists on my own team, which is because we actually deal with a lot of like financial and economic type data. So from my point of view, well, also because I was a financial quant for a while, and I worked with lots of economists, so I think of economics as a good way to get started in data science. And personally, I'm biased. I like people who study something as compared to people who just study data science or statistics. Because if you do statistics or data science, it's kind of a theoretical discipline. But if you do econ or something like I did biology, you're really studying something. Hey, Nicole's an econ major and now a data scientist. Yeah, because when you do econ or something like sociology, you're actually dealing with real data, and you think about these problems of collecting data and how to formulate a hypothesis. Whereas the truth is, if you just study data science, what do you do in a typical data science class? Someone drops a data set in your lap, and they say, run an algorithm. So you learn all the algorithms in your data science training. Well, yeah, econometrics is no joke, and that's like the real statistics deal. Like when you're actually hypothesis testing on a real set of data, I mean, that's like the real data science. And in data science class, like I was saying, you typically just get these data sets dropped on you, and then you learn an algorithm. But it's very technical. You just learn the theory of these algorithms. And a lot of data science programs, they're preparing you to understand the algorithm, like to develop a new algorithm. But the truth is, most working data scientists are not going to write new algorithms. You just take it off the shelf. And most of your actual work as a professional data scientist is what we were doing in the stream today, which is making the data set. Detox Mango, what kind of neural networks have I studied? And machine learning is linear algebra and then the data science bootcamp stuff. I've studied, I did research on support vector machines in my graduate school days. And nowadays, I play with TensorFlow and deep learning. Although it's not for my day job. In addition to streaming on Twitch and having a day job, I do mess around with some TensorFlow deep neural networks. And so I don't really cross-pollinate my neural networks with churn research, because churn is structured data, where each column is like a measurement of something. And you use neural networks for more like unstructured data, like images, audio recognition. I mean, most typically images or sentence processing, reading. So I don't really have a crossover between the neural networks and the churn. Yeah, definitely neural networks for text processing, natural language processing. Although I haven't used them for that. I've done natural language processing, but with more, just like word to vec, and I mean, the truth is, a lot of natural language processing algorithms in deep learning didn't help a lot until recently. The very recent natural language processing algorithms in deep learning, the ones that have names like Roberta and Bert, the Sesame Street characters, they actually have done some good stuff. But if you ever looked at any natural language processing from a few years ago, all the deep learning algorithms were just like, they had the same accuracy as logistic regression. So yeah, it's the adding the context. It's just in the past couple of years. Although interestingly, what we've been using at my work, I don't know if any of you know blazing text, or fast text actually. Fast text is the algorithm from Facebook. It's not deep learning, but it does really well. And as the name implies, it's a lot faster. So a lot of the deep learning text algorithms, it does like a lot of work, but it's not for that much improvement in the accuracy. It's kind of funny when you look at these studies. It's like they start out by saying, oh, we did it with logistic regression and it had 86% accuracy. And then we made a giant neural network and it had like 86.4% accuracy. And you're like, you made that giant neural network to get like 0.4% accuracy? Anyway, I should wrap it up for the day. Let's see, what's here? My next stream will be in the new year, 2021. Oh, it takes ages? I actually haven't tried, using those. And we're working with long documents at my work too. All the NLP we're doing is with very long documents, so we kind of shied away from the slow stuff. But anyway, so my next stream will be in 2021. Thank God for 2021. I don't know about you guys. But note, this is my new time. So my Saturday stream will be at 3 Eastern. My Saturday stream will no longer be European friendly. It'll be my Australia and Asia friendly stream on Saturday. And then Sunday will be the new European friendly stream. So thank you all for joining me today. Hope you found it interesting, and definitely check out I save all the old videos if you missed it. I'll highlight it and, put it up so you can check it out later. Since there's still a few people here, do you guys want to do a raid of another stream? I keep wanting to do it, but I never know, whose stream to raid. Does anyone want to raid another stream that's going on right now? Let's see, who are my recommended channels? Only in the science and technology. I knew some other quants from before. Wow, live earthquakes. I think we want to do coding. Does anyone know Misty Maps? Back to Unity. See, everyone's doing data. I mean, everyone's doing games, but no one's doing data. No tags or filters into programming. Yeah, good point. Let's see. Okay, I know some of these people. I know him, CMG Griffin. He's usually pretty funny. Making a MMO from scratch, adding Unicode character classes, RWX Rob. Alright. I'm just going to try raiding some random person. So thank you all for joining today. Hope you enjoyed. We're going to try to raid. Let's see. We'll just go with RWX Rob and see what he says. See you all again sometime. Thanks a lot. I'm trying my first raid because I'm such a Twitch noob at streaming. Haven't even done this before. Let's see what happens. Bye bye. Oh, I can't raid that channel. Who can I raid? Let's see if I can raid this other guy. We'll try Retro MMO. We'll learn about making let's see. Okay, we're going to Retro MMO. See you all there.